Okay, this is Rubina Siddiqui, and this is the pattern tutorial for my term project. So the application of design patterns begins with testing and debugging, maintaining abilities and extensibilities, collaboration, design and review planning, and cross-platform development and recurring problem solving. So this is a complete guide to design patterns and programming within it. So for the intro, we have structural design patterns, and they have 7 different ones. Or 8 different ones. We have composite, flyweight, bridge, facade, proxy, adapter, and decorator. So this is an example of adapter patterns. This is a classical example. So this one is like a printer and what a client would see and what an adapter or adaptee would see. So a client would only see a client user thing right here with client code, but they wouldn't see any of the like print void or anything like that. So the adapter pattern allows incompatible interfaces to work together. It acts as a bridge between 2 incompatible interfaces. Integrating a new payment system into an existing e-commerce platform is an example that I thought of. So this one's interesting too because you can see the client side, you can see the target, and the legacy adaptee. So for this one, the example I chose was like a drawing application with types of shapes and renderings. And the pros are 2 incompatible interfaces would work well with it, and then using existing functionality to be able to code it. And then the cons would be it's harder to use and harder to code with, and it does introduce like overhead issues with compatibility and things like that. And this is the UML diagram I made. So this would be for the payment system that I talked about earlier. So you have old payment system plus process payment, and then you have new payment systems plus make payment, and then they're connected by the payment adapter, which is process payment and new payment system. So we have a bridge pattern, and this is an example of one. So you have abstraction with the implementer, and they all basically go into the abstraction or the implementer. So the bridge pattern pros and cons. The bridge pattern decouples an abstraction from its own implementation so that the two can vary independently. Developing a drawing application that supports multiple types of shapes and multiple renderings would be this one. And that's my example, creating a drawing application that has shapes. So they all go into the shape category. So the pros would be its flexibility, and it's easy to code, and the code is organized well. And then the cons would be adding more classes is kind of harder, and it's an overkill for simple programs, just looking at the code wise. But this is the UML diagram. We use square, circle, shape, and they all have draw, and then rendering is all going into them. So for the composite pattern, here's an example. It looks kind of complicated. You got design for uniformity, and the client goes into it, and you have children on the side. And then you have design for type of safety, same thing, client, child, and components. And this is how they look. So the composite pattern allows you to compose objects into tree structures to represent part-whole hierarchies. It lets clients treat individual objects and composites uniformly. So that's why you can add and subtract pretty easily in the composite section. So for composite patterns, pros and cons, my example was building a file system with directories and files. So the pros would be simple code and it's all unified, and then it's easy to add or delete new components. Cons would be the design is really plain, and some people don't like that. But the class hierarchy could get really difficult with the more methods you add and everything. So this is my example on the side, the UML diagram. We got file system, you got add, remove, display. You got directory add, and file has display, remove, and display. So they all equal into file system. And then we have an example of decorator pattern. This one is a car, and how you have a basic model, and then you have like a more expensive model, luxury car, sports car, and how they all equal into each other. So the decorator pattern allows behavior to be added to an individual object dynamically without affecting the behavior of other objects from the same class. So this is pretty cool because nothing is affecting anything else, just the one. They're all separated. So my example of a decorator pattern was adding windows and drawing to a graph and drawings to a graph without modifying the class. So I got window, we got plus draw, we got basic window, plus draw, and then we got decorator, window, and draw. Then we have border decorator, draw, and then scroll decorator, draw. The pros are they're flexible and easier to add or remove the responsibilities. You can just minus them out or add them if you need them. But cons are the number of smaller classes, it just ends up looking kind of sloppy, and the components are not identical, so it looks weird. Then we have facade pattern. And this one, it looks a lot more difficult than all the others. So you have facade pattern demo, goes into shape maker, and then it goes into the create interface. And this is what the user sees. So you can make different shapes, circle, rectangle, square. So the facade pattern provides a simplified interface to a complex subsystem. So this is the simplified interface, and this is the backing of it. So the pros and cons for this are that there's for the facade pattern are that it's simple, it reduces coupling between clients and subsystems, and the cons are objects may have too many responsibilities and become a god object, and then it hides too much of a subsystem and it limits the flexibility is another con. So for this example, I used multimedia files for like music, and so it's called a multimedia facade, and we got play audio, play video, that has audio play and video play, and they all equal into facade, the multimedia facade. Then we have the flyweight pattern. The flyweight pattern is used to minimize memory usage or computational expenses by sharing as much as possible with similar objects. So we have a client, and the client's car information and the set info, get info, and then we have different car brands, Audi, Ferrari, and another Audi. And this is the information that the client does, or the user won't see, but the client will see. So the flyweight pattern, pros and cons. So flyweight is usually used to share common properties among objects. And for pros, we got reduced memory usage and increased performance. And then we have cons, complex code and complicated shared objects. So if you have multiple of the same objects, it just gets confusing. We have the example I did was editing graphical objects. So like a character, got display, character style, text style, factory, get style, and text style font, and they're all affected by each other. So we have the proxy pattern, and this one you can see client, factory, object, proxy, and object. So it looks more complicated than it is, but out of all of them, this is probably the most difficult one to grasp. So the proxy pattern provides a surrogate or a placeholder for another object to control access to it. So you need to invoke the object and return it. So the pros and cons for proxy pattern are it adds a layer of control access for logs and other resources, and it adds functionality without changing real objects. And then the cons are it introduces latency issues and makes it slow, and then it increases code complexity. And the UML diagram I made for the example was adding security proxy for a resource. And so we got a resource, we got request, we got real request, and then request again, and then proxy request, and then resource is real source. And that is my term project. And all these patterns are interesting because without them, it would make the cross-platform development really hard, and it makes maintainability easier. Also, the testing and debugging issues, it helps you have like a checks and balances through it. So that's very interesting. And that is it.